Hello, and welcome back to my YouTube channel. My name is Professor Govala, and today we're going to be doing two supernode examples. And this is the first one, and this is the second one. And maybe pause the video and see if you can complete these questions, and then come back to the video and see if the answer that we derive here is the same as the one you got. So for the first example, we know that a supernode is basically when we have a voltage source that is in between two non-reference nodes. So what that looks like is this 5 volt ohm resistor, this 5 volt voltage source is in between two nodes that are non-reference. So that means they're not connected to ground, right? So let's call this V1. Let's call this V1, V2, and V3. And we're going to say that coming into V2 is I1, and I2 is coming out of it, and then I3 is coming out of it here, and I4 is coming into it here. I4. So we're going to start off by writing a KCL. So this is solving for currents. And we're going to say that there's a supernode. I'm going to get rid of this voltage here. I'm going to say there's a supernode right here. So kind of connecting V2 and V3. And I'm going to say I1 plus I4, because they're both coming in, minus I2 minus I3 is equals to 0. If I were to organize that in terms of my currents, this will be I1 minus I2 minus I3 plus I4 is equals to 0. Now, I1 is 10 volts, because I start here at V1 and I subtract V2. So V1 minus V2, let me increase my pen. So V1 minus V2 over 2 plus, minus, and I2 is V2 over 8, minus I3 is V3 over 6, because it's coming here, plus I4 is V1 minus V3 over 4, which is equals to 0. We understand that V1 is 10 volts, and V1 here is 10 volts. So then now we can write an equation. We could pull out V2, and we're left with negative 1/2 minus 1/8, plus we can pull out a V3. We're left with negative 1/6 minus 1 over 4. This is equals to negative 10 over 2 minus 10 over 4. And these values are simply coming from here. For example, this is the 10 over 2. This is the 10 over 4. And so on and so forth. If you have any questions, please leave them down in the comment section below, and I'll be sure to get back to you. So to continue, we can simplify all these equations. This in decimal is 0.625 V2, plus this in decimal is 0.416 repeating V3 is equals to 7.5. And we can consider that this is our first equation. So given this, we have two unknowns, I2 and I3, and we need to find another equation to satisfy the two unknowns criteria. So in order to find the second equation, we go ahead and insert back our 5 volt source, and we can redraw that here just to make it more clear, minus plus minus. And we have 6 ohms, 8 ohms. But realistically, we don't really care too much about the elements. We care about the voltage. This is V2 plus minus V3, and this is at ground. This is a minus and minus because it's closer to ground, so it's a lower potential than this plus and plus. And we can write a KVL now, right? So around this loop. So this is minus V2. This was 5 volts. Minus V2 plus 5 volts plus V3 is equals to 0. And you can see then that this is going to give me V2 minus V3 is equals to 5 volts. I basically moved this to the right-hand side and this to the right-hand side. And also, you can see by inspection that this is at a higher potential. V2 is at a higher potential than V3. So V2 minus V3 needs to equal to 5 volts. And as a result, now we have our second equation. And then now it's just algebra. So what I'm going to do here is I'm going to say that V2 is equals to 5 plus V3. I'm going to insert V2 in here. And I'm left with 0.625 times 5 plus V3 plus 0.416 repeating times V3 is equals to 7.5. And again, this is going to be 0.625 times 5 is 3.125 plus 0.625 V3 plus 0.416 V3, which is equals to 7.5. If you add these two up, you get 1.041 is equals to, if you subtract 3.125 from 7.5, you're left with 4.375 V3. Oh, sorry, this is the V3 is on this side. And as a result, V3 is equals to 4.202 volts. So this is your answer for V3. We can go ahead and plug this into here. And V2 is equals to 9.202 volts. This is what you should have obtained. If you didn't get this, please let me know in the comment section below, and I'll be sure to get back to you with the to get back to you if anything was wrong. So let's go to the second problem. The second problem as well is also pretty simple. We have to understand that this is a supernode, right? V1 and V2. And we could write our currents as such. So this is coming in here as I1. I have it here as leaving as I2. This one is leaving as I3. And this one is also leaving as I4 because they're all going to ground, right? They're all connected to ground. So basically here, I1 is equals to I2 plus I3 plus I4. Again, I might have skipped a step here, but just to be completely transparent, imagine then now that this is a node, a supernode on its own. So essentially the currents coming, as this is a supernode on its own, so essentially the currents coming in are the currents leaving to go to ground. All right. So what could we say here now? We could say then that, again, this is KCL, right? So we're solving for currents. The current for I1 is it's leaving from 21 volts minus this V1 over 4 ohms, and it's equals to I2 is basically V1. It's starting at V1 and going to ground minus 0, but I'm not going to write the 0, or okay, I will. V1 minus 0 over 3 plus V2 minus 0 over 2 plus V2 minus 0 over 6. And that's for I3 and I4. So then we can keep going and saying that 21 over 4 is equals to V1 1 over 3 plus 1 over 4. 1 over 4 comes from here. 1 over 3 comes from here. Plus V2 1 over 6 plus 1 over 2 plus 1 over 6. Again, that comes from here, and that comes from here. We can further simplify this as 21 over 4 is equals to 7 over 12, which is this here, V1, plus 8 over 12, which is this here, V2. If we go ahead and multiply this entire thing by 12, we get that 21 over 4 times 12 is 63. This is equals to 7 over V1 plus 8 over V2. And we're left with this as our first equation. So in order to get the second equation, I'll do it on this side, we need to put back that voltage source that was here at the supernode. And I'll go ahead and redraw it. And using KVL now, right? So again, this is a voltage V1, and this is a voltage V2, and this is 9 volts. Imagine there's a loop. We go around the loop using KVL, and we say minus V1 minus 9 volts plus V2 is equals to 0. So again, this could be set as V2 minus V1 is equals to 9 volts. This is our second equation, right? And this makes sense, right? Because V2 is at a higher potential, right? It's at the plus terminal, and V1 is at the lower potential. So V2 minus V1 must equal this 9 volts, right? And we can do our two equations, two unknowns. We could say that V2 is equals to 9 plus V1, and go ahead and insert that. I'm going to go ahead and insert that in here, and I'm left with 63 is equals to 7 V1 plus 8 times 9 plus V1. And we could say then that 63 is equals to 7 V1 plus 72 plus 8 V1. We do the algebra. 63 minus 72 is negative 9. 7 plus 8 is 15 V1. And V1, negative 9 divided by 15 is negative 0.6. Go ahead and plug this back into here. And V2 is equals to 9 plus negative 0.6, which is equals to 8.4. And lastly, let's say we wanted to find the current. Let's say we wanted to find the current through this 2 ohm resistor. Let's call it I. So I, maybe pause the video and solve it. But I is equals to 8.4 over 2. Right. Again, this is, let me rewrite. This is V2 divided by 2 ohms. And this is 4.2 amps. I forgot to put my units. This is in volts. This is 0.6 volts. All right, so I hope this makes sense. If you have any questions on how to do Supernode, or if you want to see more examples, please let me know, and I can upload more videos and examples of this. And please like, subscribe, and share my YouTube channel. Thank you. Have a wonderful day. Bye.